Hello, this is Year 1 Mechanics from Pearson book. It's 10.6 Pulleys and it's example 13. Let's start by reading this. As particles P and Q of mass 2m and 3m are attached to the ends of a light, inextensible string. The string passes over a smooth fixed pulley and the masses hang with the string taut. The system is released from rest. I'm now going to draw a diagram. So I've drawn a sketch of a diagram and now I need to put some more detailed information on there. To start with, if I look on the left hand side, I have a mass of 2m, which means that's going to have a force acting downwards of 2mg. And the same here, we're going to have a mass acting downwards of 3mg. And it's also going to help us to know which particle is which. So this here is P and this here is Q. And from the question, it says that the string is taut. So when a string is taut, this means that it is in tension. So tension is acting up there, like that, and also like that. And when I come onto the here, the tension again is acting there, and it is the same value for tension. The value for tension is the same throughout the system because it is one piece of string, and therefore the tension will be constant throughout it. It then says the system is released from rest. So if it released from rest, it's then telling you it's then going to start moving, and which way will it move? Well, the heaviest mass between the 2m and the 3m is 3m, so it's going to start moving in that direction. So it's going to accelerate that way. Therefore, the 3m mass will move downwards and the 2m mass will move upwards with the same acceleration because they're connected particles. So it's quite important. This is the same knowledge as connected particles that you've already used previously. Now moving on to A, it asks us to write an equation for the motion for P. So resolving vertically, using F equals ma. Now when we do this, what we need to do to help us is if we draw a little dotted line just across here, it can help us just see the forces that are only acting on particle P. So we're just looking at this particle P just here. And when we're looking at particle P here, the forces that are going in the direction of motion is T. So T is going in the same direction. So it's this T here is going in the same direction as the motion. And also we have got going in the opposite direction, so opposing that motion is 2mg, so we take that away. So T that I just circled there is going in the direction of the acceleration of the motion, and 2mg is acting against it, so we take that off, and that must equal our mass, which is 2m multiplied by our acceleration. So we have our equation now for P, which is T minus 2mg equals 2ma. Moving on to part 2, you're asked to find or write down an equation for the motion of Q. So again, resolving vertically, using F equals ma again, because the particle is accelerating, therefore we can use F equals ma. So we've got to look at the forces, and we're looking at particle Q now. What forces are acting in the direction of motion? Remember, you need to look at the acceleration and you need to look at particle Q for this. So in the direction of motion, the particle is moving downwards. So the positive force is 3mg, and opposing that motion is tension. And that is equal to your mass, which is 3m, multiplied by your acceleration. And now I've found the equation for Q. Moving on now to part B. Part B asks us to find the acceleration. To find the acceleration, I have above in part A, part 1, I have one equation which has t and a in it, and in part 2 I have a second equation. So I actually can use simultaneous equations to find A. And if I want to find A, I need to eliminate t. To eliminate t, I would add my equations together. So t, take t, they would be eliminated. Negative 2mg, add 3mg would be mg. And on the other side of the equal sign, I've got 2ma, add 3ma, which is 5ma. And therefore, I can write that my acceleration equals g over 5 meters per second to the minus 2. And if I use my answer at any point later in the question, that's the one I'm going to use because that's the most accurate, but also allowing for that to 3 significant figures, which is where I'm going to work to for the moment, I would write 1.96 meters per second squared. So that's my solution for acceleration. Now we move on to part C. And part C asks us to find the tension in the string. So this brings me back again to my simultaneous equations, because I have 2 equations previously which had t and a in them, and I've now just worked out what a is. So for part C, I can take my first equation, which I labelled number 1, and I can replace acceleration with g over 5. Notice I've gone back to the most accurate one. So t minus 2mg equals 2m times or multiplied by g over 5. Now, because 1.96 is exact, it would be fine to use it. However, later on when you do a question and you actually get involved in rounding, going back to that fractional answer keeps a level of accuracy throughout the question. Therefore, I can now write t equals 2mg over 5, add 2mg. Here comes your fraction skills. So we need a common denominator to make this work. So I'm going to write that, because that would be an equivalent fraction, and that would give me 12mg over 5. And that's part C completed. So part D. Let's go back up and look what part D wants us to do. Part D wants us to find the force exerted on the pulley by the string. To do this, I'm going to need to start by drawing myself another diagram. This is my new diagram for D, and what you'll notice is I've just focused on looking at the pulley. So I have a pulley and I have acting down tension. So the force exerted on the pulley is equal to 2t. But I've already worked out what t is. If I just go over here, t is 12 mg over 5. So using that knowledge, that's going to be 2 times 12 mg over 5. And that would be equal to 24 mg over 5. And that would be newtons. Remember that there is newtons. I've just noticed here, I've forgotten here, that should be newtons. And because otherwise if I don't write my units on, I can lose marks. So part D, 24 mg over 5 newtons. Right, now I'm going to move on to part E. So let's go back and look what part E says. It says find the distance moved by Q in the first 4 seconds, assuming that P does not reach the pulley. So we're looking here at Q. We know that it started from rest, so we know that U equals 0. And we know the acceleration. And we know that we're talking about time. So let's go down here and write down all the information we have. So for E, I know initially U equals 0. I know that the time we're asked for in the question is 4 seconds. I just need to scroll back up to my workings on my acceleration, and I'm still going to use that g over 5. Now you'll notice that that doesn't look like an S, so I'm just going to alter that so I can see that's S. Handwriting can be an issue in mechanics. And S's looking like 5s can cause you problems. And what we've been asked to find out, if you think about it, is our displacement. So this is going to be suvat. So which formula would I use? I'm going to use S equals ut plus half at squared. S equals, well, ut, that would be 0, because as u is 0, that means that term will be 0, plus half multiplied by 9 over 5 multiplied by 4 squared. Remember that g is 9.8, and you would type that in your calculator, which I shall do, which gives me an answer of 15.68 metres, as it's important again that I do remember my units. And if I'm going to 3 significant figures, I would then put 15.7 metres, but I'd just say that that's 3 significant figures so that I know that I have rounded. So coming to the last stage of this question, F, we just need to scroll back up and remind ourselves what it's asking. So state how you've used the fact the pulley is smooth in your calculations. Well, it's really important that the pulley is smooth, as I said before, or it does make modelling so much more difficult. And one of the ways that you could say that this has helped us is that the tension in the string is the same at P as at Q. Now, it is worth building a bank of these comments up and having them there for you to review. Yes, it's great to store them and know them, and that's what I would prefer. But if you struggle with these, write down these questions and just these one-line questions, and then write these answers and build up a crib sheet. And that way you'll have that there, and it's fantastic for when you actually move on to answering those A-level exam questions, because you know exactly what the examiner's looking for when they ask for those modelling assumptions that you have made when answering those questions. But that's the full workings for example 13.